Hey guys, welcome back to Techness Arena, your core channel for all things tech. Today, let's try to merge two terms together, data and mathematics. Is there a relationship between them? The big question we'll be exploring is math really needed in data fields? And if yes, how much knowledge of math should you have? Stay tuned because I'll also be explaining the key concepts that are important in data roles. So, let's find out this together. Alright, let's kick things off with a fundamental question. Is math truly important in data jobs? The short answer is yes, and here's why. Data, at its core, is all about patterns, relationships, and making sense of information. And guess what? Math is the language that helps us describe and understand these patterns. To put it simply, math provides us with the tools to analyze and interpret data. Whether you are dealing with the raw data sets or crafting complex algorithms, having a solid foundation in math can make a world of difference in your ability to draw meaningful insights from the data. Now let's narrow our focus a bit. Is math specifically needed in data analytics or data science? Absolutely. In data analytics, you'll find yourself working with various statistical methods to uncover trends and patterns. This involves concepts like probability, regression analysis, and hypothesis testing. But if you're just starting out or looking for an entry level data analyst position, then you don't need to take that much stress for maths. It's a plus if you're good at basic mathematical concepts, but don't just get stuck at one position, especially for a data analyst role. In the realm of data science, the use of advanced mathematical techniques becomes even more pronounced. You might encounter linear algebra when dealing with machine learning algorithms, calculus when optimizing models, and probability theory in areas like Bayesian statistics. So, if you are aiming for a data scientist position, then you need to build some mathematical skills. The burning question: how much math is really needed for a career in data? Well, the answer depends on the specific role you are aiming for. If you are looking to dive into entry level data analysis, a good grasp of basic statistics and arithmetic might suffice. However, as you climb the ladder towards roles like data science or machine learning engineering, you'll find yourself needing a deeper understanding of mathematical concepts. Linear algebra, calculus, and statistics become your champions in this journey. But here's the key: you don't need to be a mathematical genius. A solid foundation and the ability to apply mathematical concepts to real world problems will take you a long way. Alright, let's break down some essential mathematical topics and concepts you should familiarize yourself with. Let's jump into the intricacies of mathematical concepts essential for anyone venturing into the data science realm. So, I've broken everything down and made a list of topics that will serve as a roadmap in understanding the mathematical backbone of data science. First up, statistics is the bedrock of data science, helping us make sense of the information we encounter. Descriptive statistics like mean, median, mode, and measures of variability provide a snapshot of the data. On the other hand, inferential statistics involving hypothesis testing and regression analysis enable us to make predictions based on the samples. Moving on to linear algebra. Think of it as the language of machine learning. Vectors and matrices are the building blocks representing and manipulating data. Eigenvalues and eigenvectors came into play in algorithms like principal component analysis, unraveling the underlying structure of our data. Next on our journey through math is calculus. Differential calculus helps us understand rates of change, crucial for optimization algorithms in machine learning. Meanwhile, integral calculus steps in for calculating cumulative effects and areas under curves, especially in probability distributions and optimization problems. Now let's talk about probability. Basic probability concepts, such as probability distributions and conditional probability, lay the groundwork. And as we dive deeper, statistical probability models become essential in the realm of machine learning algorithms. Optimization is another key area. Gradient descent takes center stage at iterative optimization algorithm, a workhorse in training machine learning models. And when real-world problems involve constraints, we turn to constraint optimization, employing techniques like Lagrange multipliers. Don't forget about discrete mathematics. Graph theory comes into play in network analysis, exploring nodes, edges, paths, and connectivity. Meanwhile, combinatorics is crucial for counting and arranging elements, featuring concepts like permutations and combinations. Information theory adds a layer of understanding with concepts like entropy, measuring the amount of uncertainty in a set of data. This is crucial for deciphering the information content of variables. Let's not overlook the specific mathematical concepts within machine learning. Whether it's supervised learning with regression and classification, unsupervised learning involving clustering and dimensionality reduction, or understanding the basics of neural networks with activation functions and backpropagation. These are the nuts and bolts of modern data science. Now, here's the key takeaway. While grasping these mathematical concepts is undeniably beneficial, the landscape of data science is evolving. And many tools and libraries like NumPy, SciPy, and scikit-learn in Python provide pre-built functions for these operations. However, a solid understanding of the underlying principles empowers you to choose the right methods, interpret results accurately, and troubleshoot any challenges that may arise during your data analysis or modeling journey. Time management is key, especially when diving into the world of math for data fields. The amount of time you should spend on math depends on your goals and the specific field you are interested in. Start by building a strong foundation in basic math and stats. As you progress, gradually introduce more advanced topics. Remember, it's not about cramming everything at once, but about understanding and applying concepts. Allocate dedicated time each week to brush up on your math skills, and you'll see noticeable improvement over time. So, is math really needed in data fields? Absolutely. The extent of your mathematical journey depends on your career aspirations within the data domain. Start with the basics, gradually delve into more advanced topics, and always apply what you learn to real world scenarios. Alright then, that was all for this topic.
If you found this video informative, don't forget to hit that like button and subscribe to Techness Arena for more informative insights. And I'll see you in the next video. Until next time, keep learning and keep exploring.